So how about when we start to look at stresses in the diving board itself? Well, one of the examinations asks students where the maximum moment is in the diving board itself. You can still use body diagram for this process. So for example, if I take it at some point here very close to the diver and free body diagram around here, I can simply say I have almost no eccentricity. Nothing connects the structure to the rest of the universe here, but at this point here I must have a moment that restores the applied moment. And all it will tell me is that once I approach zero, the moment there approaches zero. So the moment underneath the diver is in fact zero. And beyond the diver, there is no load, so the moment is also zero. If I then draw another free body diagram around right up to point B, I can start to do the same equations, and it will tell me that the moment at this point, in fact, half a kilonewton times 2 meters, 1 kilonewton meter. So we know then at this point here we have a value of 1 kilonewton meter. Engineers like to draw bending moment diagrams for this structure. The bending moment diagram would then be maximum here. It's linear in between because there's no applied moment, and then it would actually just be flat, which is trivial to the end. So this is a measure of the moment in the diving board. So 1 kilonewton meter here, 0 here, half a kilonewton meter halfway in between. If we apply the same theory to point A, what that simply tells us is that at A the moment is also 0. Between A and B there is no applied load, and therefore this is the shape of the total bending moment diagram. So if the diving board was to snap due to flexural failure, presuming it was constant material, it would snap at point B, and the maximum tension in the board would actually precisely be at point B, but also in the top surface of the board. Because in the board itself, through the thickness of the board, the stresses would be distributed in the zigzag pattern, which is in the lecture notes. Tension at the top, compression at the bottom, and nothing in the neutral axis.